The Maurer Girder Grid expansion joint is the classic system for watertight expansion joints with an expansion range from 80 to 640 mm. The support bars of the Maurer Girder Grid expansion joint are parallel to the primary movement axis, while the beams are arranged parallel to the edges of the bridge structure. The edge beams are rigidly anchored in the structure. In order to avoid material fatigue, traffic loads are transmitted to the abutting reinforced concrete construction via anchor plates. The support boxes, which provide the support bars with room to move, have welded stud shear connectors for permanent connection to the abutting concrete. With steel construction bridges, the edge structure is placed on consoles or support girders parallel to the end cross girders. Every center beam of the girder grid expansion joint is rigidly welded to the support bars allocated to it. Thus, a girder grid which can be moved within itself is created. Springs, positioned between the support bars, control the equal separation of the center beams from one another in relation to the total width of the joint gap. In addition to the conventional movements along the roadway axis, secondary movements can also occur. For example, rotations due to uneven temperatures, or translations from abutment movements and elasticity of the bearings. The Maurer Girder Grid expansion joint is capable of accommodating such movement to a certain degree. The control springs, positioned between the support bars, or between a support bar and the side wall of the support box, are made of primarily cellular polyurethane, with high damping characteristics, and ensure a uniform distribution of total movement to the entire joint gap. The high level of permissible deformation, up to 80% compression deformation in relation to the uncompressed initial length, makes it possible to build elements with even higher permissible spring movement ranges and comparatively small dimensions. The material's inherent damping also causes vibration damping and shock damping of the components,